All right, so here's that first page. The odd answers are on that old CalcChat link that I posted right in the assignment. And then these were the evens, which were also posted. You could have on the first page skip that 127. You're not going to have to prove that it's the inverse. Obviously, you can use that to check questions like 129 and 130, but you don't actually have to go through that process. So 103, 104, adding, subtracting. 117, 118, multiplying. 129, 130, finding the inverse. Any questions on those?
You did the inverse.
Yep.
Inverse problems.
So I'll do 129 because the answer's not here. So remember, you do like the fish. So I would do 4 times a negative 6 minus negative 5 times 5. And you get negative 24 minus a negative 5, which becomes, minus a negative 25, which becomes plus 25. And my inverse would just be 1. So I put 1 over 1. This would be wherever that number went. This time it just happens to be 1. And then I multiply it times the negative 6 and the 4 switch locations. So 4 comes to the top left, negative 6 goes to the bottom right. And then the negative 5 and the negative 5 change signs. So this time it looks like they have also changed positions, but they're changing signs.
That happens to me almost every semester.
Yeah, it happens a lot of times, to be honest. I purposely made them on the test so they are not like that.
Okay. So if it was the other way around.
So this one,
It would be just.
which it's also like this is 3 times negative 3. I don't know why your book loves to make them 1, but this is negative 9 plus 10, which is 1, right? It would be 1 over 1. And then this time you switch them, so we're switching these. 3, negative 3, and then you're changing the sign on the 5 and the 2. So I'd get 3, 5, negative 2, negative 3. Here, I can make one up that's not that.
What happens if like both of them are like negative or both of them are positive?
Inside the one on the changing of the sign.
Between
So if it's like
5.
4, negative 2, negative 5, and 7, let's say,
Yes.
right? So I do 7 times 4 minus a negative 5 times a negative 2, 28 minus a positive 10, and that's positive 18. So I get 1 over 18, and then switch the 7 and the 4, change the signs on the 2, the negative 2 and the 5. So whatever sign they were, they are now the opposite. And then I'd multiply that in. So it'd be 7 over 18, 2 over 18, 5 over 18, and 4 over 18. And then whatever can be simplified, you simplify. So 7 over 18, 1/9, 5 over 18, and 2/9. And this one goes right on your answer sheet. So all the matrix answers goes right on your answer sheet. If you are going to be at home tomorrow, so either you're an in-person person that likes to stay at home on a day of a test, or you're an actual stay-at-home person, you need to print that answer sheet, okay? And if you don't have a printer, you need to look at that answer sheet and model a blank piece of paper after that answer sheet. The boxes need to be in the order they're in. They need to be in the spacing that they're in. And then at the end, you'll see the Cramer's rule ones are divided. So for the one with 2 variables, it's divided into 3 sections, one for dx, one for d, then dx and dy. And then the Cramer's rule with 3 variable, it has 4 boxes, one for d of x, one for d of y, and one for d of z. You need to make sure that you make it easy on me to find your work, because obviously I have to grade all that stuff. Any other questions on this first page? Everybody good from home? This is today, I should make them split their screen. And multiply
No, not that. Like the dimensions, like.
of the result.
Yeah.
So when you write, so like I'm going to say that this is a 3 by 2 and this one is a 2 by 3, right? The inner 2 is your test to see if you can do it. The outer 2 is the result of the product.
Right, okay.
So that would have been a 3 by 3. And then 18 can't be done because the number of columns in A don't equal the number of rows in B. Or the middle 2 numbers don't match. Something like that. Like if you can't do it, you'll give it to me in your own words.
So for multiplication, they can be different dimensions, but not for addition and subtraction.
Correct. Addition and subtraction has to be exact same. Multiplication, middle 2 have to match.
Do you do 180?
Well, it can't be done. So no.
Oh wait, no.
Like 117? Yeah. Okay, so 117 would be, we just said the inner side would be 2, so that match, and the outside would be a 3 by 3. So I know I've got a 3 by 3, like a tic-tac-toe board. I'm gonna do row 1, column 1 first. So I'd get 1 times 6 plus 2 times 4. 6 plus 8, which is 14. Then I go to row 1, column 2. I'm moving too fast for explaining everything. Row 1, column 2. And I get 1 times negative 2 plus 2 times 0. Negative 2 plus 0, negative 2. Row 1, I'll just do it in a different color. Column 3, 1 times 8 plus 2 times 0, 8 plus 0, which is 8. Then we go row 2. Row 2, column 1 would be 5 times 6 plus negative 4 times 4. 30 minus 16, which is 14. Row 2, column 2, 5 times negative 2 plus negative 4 times 0. Negative 10 plus 0, negative 10. Row 2, column 3, 5 times 8 plus negative 4 times 0. 40 plus 0, 40. Then we go row 3. So row 3, column 1, 6 times 6 plus 0 times 4. 36 plus 0, which is 36. Row 3, column 2, 6 times negative 2 plus 0 times 0. Negative 12 plus 0, which is negative 12. And row 3, column 3, 6 times 8 plus 0 times 0. 48 plus 0, which is 48. And then we rewrite just the system, just the matrix. 14, negative 2, 8, 14, negative 10, 40, 36, negative 12, 48. So, sorry, go ahead.
Oh, sorry. If this was like a 3 by 3 by 3 by 3, would you, let's say like the first row, would you?
You'd have 3 things, you'd have 3 pairs to multiply.
Yeah, okay.
Yeah. So it's still row 1, column 1, but there'd be 1 and 1, 2 and 2, 3 and 3, and then you'd add them.
Okay.
Yep. So remember, if you are taking this at home, you need to print your answer sheet, okay? If you don't have a printer, you need to get out a piece of white paper and make it look like the answer sheet. The biggest thing here is just the organization. There's not any graphs or anything like that, but I did separate out the rows and that kind of stuff, and especially when you get to the determinant, you need to the Kramer's rule, you need to make sure that one box is separated into 3 for D, D sub X, D sub Y, and then the other one is D, D sub X, D sub Y, D sub Z, so that it's easy for me to find. All the answers that are matrices, which is the adding, the subtracting, the multiplying, and the inverse, you will leave on your answer sheet. And then the things like the area, the collinear, non-collinear, your Kramer's rule, those answers you'll type into Canvas, but you'll still have all the work on the paper. And again, I'm going to be super picky about the work. Obviously, these can be done in different ways, and I want you to do them the way that we're learning them right now. So if you magically solve the system, but you don't have Kramer's rule to back you, I'm taking away all those points. For the 2 variable, it's 10, and for the 3, it's 20. So don't do that, okay? I'm not going to feel bad and give you a little bit of credit for solving a system in a completely different way than you're supposed to be doing it. So just keep that in mind. Yeah.
Since we're in person, are we doing it all on paper?
Yeah, I have your paper ready to go. Yeah, I think it's so much easier to do it on paper. I feel bad for people at home because you're going to have to be so careful to rewrite. You guys don't have to rewrite. Yeah.
Are there going to be 3 by 3 numbers?
No.
Because there's like practice ones.
I know, but in the directions I say don't do them. Yeah. Jacob.
How many questions is it?
9.
You said 9.
Yep. 2 adding, subtracting, multiplying from that section. 2 adding, subtracting, scalar. 2 multiplying. 1 inverse, 1 area, 1 collinear, 1 Kramer's rule 2 variable, Kramer's rule 3 variable.
And how much time is that?
40 minutes. More than enough if you know what you're doing. If you have to look up how to do things, then you're in trouble.
Is this find the area of the triangle or rectangle?
Triangle. All right, then we crossed out on this one the inverse where you had to check it. Obviously, I'm not going to make you check it. If you have extra time and you want to check your answers to like 129 and 130, you can, okay? But you don't. All right. Then came 7, 8. So I crossed out 7, 7 because you used the determinant in 7, 8. So we obviously used the determinant. but you're not gonna have a flat out question that just says find the determinant. So 7-8 starts with the finding of the area, and then the collinear, and then the Kramer's rule. Any questions on those?
It's Chris Weiser.
Yeah.
The directions for the assignment says skip the 3x3 in first. Which one is that first?
On the picture that's loaded that has the answers, there's a thing that says extra 3x3 inverse practice. That's what you can skip. Yeah, so it's not on the PDF, it was on the answers.
Okay, thank you.
You're welcome. So this is, let me go 7. Section R, 167. This area was 16 square units, 171. This area 13 over 2, which will be 6.5 if you're typing this in, and those questions will get typed in. Yeah. Oh, I'm looking at the answers. I'm just that smart, Maria.
It's like 1050586.
No, ma'am. I'm totally looking at the answers. 175 was collinear, and 177, 1-2 is your answer. Have one where you have to prove it. And then on the second slide, I crossed out all of 7-7. That's the determinant, which there's not any straightforward find the determinant questions. Obviously, there's the application ones, which are like 167 and 171, the areas. 175, the collinear. 177, the Kramer's rule with 2 variable. Sure. So I want to rewrite out the x and y's for each of these. And then the column of ones, duplicate the x and y columns, and then multiply down. So I'd get -1 times -9 times 1, that's +9. 7 times 1 times -3, -21. And 3 times 15, that's 45. So this is -12 plus 45, that's 33. Yeah.
Which problem did you cross out? 155, 157?
150,
And then 59, 60.
all of 7-7. Yeah,
I guess I didn't know, what are the minors and cofactors?
we didn't do it. Remember I said there's a different way to solving a system using minors and
Oh.
cofactors? No, it's to finding the determinant. And I didn't teach it to you.
But like
That's the one that you crossed out.
59, 61 is just part of figuring out the determinant, like, that we use in 7A, right?
Right, you just don't need a straightforward question.
Right,
Yeah. Okay, then the red diagonal is going back the other way. This is 27, -15, +21. So this is 12 plus 21, that's 33. 33 minus 33, and it's this one minus that one, is 0, which makes this collinear. So if it's 0, it's collinear. If it's not 0, it's not collinear. So obviously that's a 50-50 shot of guessing, but if you don't have the work, I take back those points. Yeah, you have to have the work of the determinant.
So the determinant will also be 0.
The determinant, say again?
So the determinant will be 0.
If it's collinear. Yeah. And then the last 179, 47, 181, -1, 4, 5, and 183. This one wasn't a whole number, 0, -2.4, and -2.6. You will get whole numbers. I mean, the process is obviously the same, but you will get whole numbers for tomorrow. Like I said, I warned that I haven't even made the makeup for this, and by the time I get to the makeup, I've usually run out of problems. So you could see fractions on the makeup, okay? I don't think they're that big of a deal with Kramer's rule because you wait all the way till you get to the end to make that fraction. It's not like you have to work with that fraction. So I don't feel so bad, but just know that that could happen. I'm just making claims for tomorrow's test. I have not made the makeup yet. I had a couple people reach out and say that they've got like an athletic event tomorrow. Thank you, 1, for reaching out and trying to be proactive. 2, please, please, please find a way to get to class tomorrow. Remember, I'm not here Thursday, Friday, Monday, Tuesday, so the makeup won't happen. And I have a meeting after school Wednesday already. the meeting won't happen till the earliest next Thursday. So over a week later, and will already be into sequences and series, and you don't want to do that, okay? No one ever does better on the makeup. All right, so just a couple of like housekeeping stuff. Please make sure you check your settings. So you're gonna do this with me now. Everybody at home, split your screen for me, please, so that I can see that your face is in front of my face. Everybody at home, split your screen, put your camera on. You all look so beautiful this morning. Thank you for joining us. It's lovely to see your faces. All right, everybody is going to go to their settings right now and check to make sure that when you click on page was your 3x3 systems, or no, sorry, one more 2x2. The 179 is 47, 181 is your 3 variable, -145, and 183. This one had decimals in it. I don't think it's that big of a deal to have a decimal, but I didn't give you any for tomorrow. I'll say it again. I don't know what the makeup's going to look like. There's only so many perfectly rounded numbers that we can come up with for a system. So I'm not making any promises on the makeup. But for tomorrow, I know none of the questions that have 3 variables have fractions.
Wait, so some that have 2 variables?
Don't have fractions.
Yeah.
Not tomorrow.
Basically come tomorrow.
So we get a fraction tomorrow.
Correct. Stop and go back to the beginning and find your mistake. Yeah.
So basically just come.
Jacob, I wish I could make you do the thing on video on Notability, because what you did, I graded your thing yesterday. It was so entertaining.
What?
Your Notability. So this is how Jacob saw